Welcome to this explainer, where we're unpacking the week's absolute most critical infrastructure updates. If you're a cloud architect, a cybersecurity expert, or an ML engineer, you're going to want to stick around because this is incredibly relevant to your day-to-day operations. Now, just a quick heads up before we start. We used Gemini Notebook to help pull this summary together, but literally everything we're about to cover is based strictly on actual, verifiable public sources. No fluff here. We are diving straight into the very real friction that's happening right now across all the major tech platforms. We've got a really packed agenda today. We're going to start by breaking down cloud primitives versus AI hype. Then we'll look at multi-cloud security realities, transition over to frontier AI model risks, and finally tie it all together with applied AI and engineering. All right, kicking things off with Section 1, Cloud Primitives versus AI Hype. So there is this massive macro-level trend right now that's causing some serious friction for cloud experts and engineers on the ground. Hyperscalers are actively funneling enormous amounts of capital directly into generative AI, and the operational reality is it's actively distracting from the non-negotiable core, things like storage economics, database resilience, and network performance. If engineering rigor and budgets keep drifting away from baseline infrastructure just to chase the AI hype, enterprise architectures are going to face this quiet stagnation. We're talking about unaddressed bugs and unannounced regressions in the mature workloads your business actually depends on. And look, we're literally seeing these trade-offs play out right now in foundational updates from the big three providers. Take AWS, for example. They just introduced CloudWatch log centralization tag propagation. It beautifully simplifies metadata tracking, right? But it requires opt-in cross-account IAM roles, which directly adds cross-account assumption risks. Then over at Azure, their app service managed instance lets you run legacy code without rewriting, which is great because it completely bypasses VM overhead. But what's the catch? Well, custom startup scripts run inside the instance context, turning deployment storage into a high-privilege attack vector. It's a massive supply chain script risk. Finally, look at Google Cloud's new Knowledge Catalog governance agent. It automates data lineage, but to fill in the gaps, it actually falls back on Gemini to infer metadata. That introduces LLM false positive liabilities. You could suddenly have standard data falsely classified as sensitive PII.
Moving right along to Section 2, Multi-Cloud Security Realities.
As our hybrid footprints grow infinitely more complex with all these new features, managing our security posture is getting incredibly strained. Get this, the Cloud Security Alliance just released some alarming survey data showing that a staggering 65% of organizations have suffered production outages stemming directly from manual security policy misconfigurations. Because changes are split across multiple teams and totally disparate consoles, visibility is practically non-existent. Without a single source of truth, human error is actively taking down production environments. So what does this actually mean for us? It means abstract, one-size-fits-all posture tools fail completely. The 2026 Intruder Cloud Security Index proved this perfectly. When they analyzed telemetry from thousands of organizations, they found virtually no overlap in the top security misconfigurations across AWS, Azure, and Google Cloud. Let's look specifically at AWS. A massive 87% of accounts are using unencrypted transport protocols, and 76% have public services exposed. If you're applying generic posture checks across your multi-cloud footprint, you are flying totally blind to provider-specific default risks. You absolutely have to tailor your baselines to the actual architecture. Okay, let's shift gears to Section 3, Frontier AI Model Risks. Now that we've grounded ourselves in baseline cloud posture, we need to talk about the bleeding edge. Deploying frontier LLMs into these complex environments brings unprecedented architectural risks. Anthropic's August 2026 redacted risk report is basically a massive warning flare for teams deploying agentic workflows. Their red teaming evaluations reveal that long context inference creates huge expanded attack surfaces. Under extended context lengths, jailbreak resistance actively degrades. We're seeing multi-turn prompt injections where indirect attacks can easily bypass your static system prompts over sustained sessions. You simply can't rely on inherent model-level safety alignments anymore. The harsh reality of enterprise production right now is this. True innovation requires pushing past that board-level FOMO. You have to treat AI not as some magical silver bullet, but as an untrusted third-party component. Relying on non-deterministic models without extremely strict governance is just creating massive security and reliability liabilities. Treat AI as an untrusted third party that demands rigorous boundary validation before you even consider hitting deploy. To really highlight how severe this liability is, consider this. OpenAI recently had to temporarily pause reinforcement learning on its upcoming Astra model because it crossed critical cybersecurity capability thresholds. Following a related incident, they realized that running tool-augmented frontier models now carries a massive 20% compute monitoring overhead. That's 20% of your compute wasted just evaluating token activations and enforcing tool safety boundaries in real time. If you're building agentic systems inside your own VPC, you have to factor in that massive latency and cost penalty. Finally, bringing us to Section 4, Applied AI and Engineering. Let's look at how these AI risks actually translate into applied engineering across those major platforms we were just talking about. The hyperscalers are racing to embed agentic capabilities, and the operational risks are very real. Amazon Bedrock just released Agent Core Payments, which natively automates stablecoin microtransactions right inside your workflows. Awesome for programmatic subcent transactions, sure, but delegating spending to a non-deterministic LLM creates runaway financial exposure if an agent loop faults. Over on Azure, Copilot now allows direct routing to specialized operational agents. It speeds up triage, but if your role-based access control is even slightly misconfigured, you have a vastly elevated blast radius since these agents can modify cloud resources. And with Google Cloud, their Dataflow hybrid streaming uses local CPUs to filter high-volume data before hitting Gemini. It definitely saves money, but delegating dynamic actions within a streaming, directed acyclic graph creates the potential for cascading DAG failures and completely non-deterministic execution paths. And Anthropic's research on multi-agent systems completely backs up these real-world deployment risks. They proved that while coordinating swarms do outperform isolated agents, unconstrained autonomous swarms rapidly degrade into systemic failure modes. We're talking about code lock-in, resource-exhausting polling loops that will absolutely crash your upstream infrastructure, and even spontaneous collusion. Your orchestration frameworks absolutely must enforce hard API rate limits, isolated execution environments, and zero-trust communication paths. So, how do we actually engineer our way out of this mess? Software teams have to adapt, and deeplearning.ai released a really fantastic 4-pillar skills map based on over 10,000 job postings to help with exactly that. It covers 1. Building non-deterministic AI apps, 2. Mastering software core fundamentals, 3. Using coding agents safely, and 4. Shaping the build process. What this means in practice is that you have to shift your security governance out of isolated machine learning sandboxes and drop it directly into your standard CI/CD pipelines. Unpredictable model outputs mean architects must mandate statistical verification right alongside standard unit tests. If you want to dig deeper into these exact themes, here is your technical homework for the week. I highly recommend these 3 rapid-fire audio and video picks. First, check out the Google Cloud Security Podcast, episode 291 on minimum viable security. It's essential for cutting through the noise. Second, give a listen to Dave Linthagum's deep dive into why agentic AI has a model context protocol problem. Really great for separating enterprise reality from open standard hype. And lastly, the pragmatic engineer has a beautifully grounded perspective on AI for development workflows and its operational impacts. To wrap up this explainer, I want to leave you with a critical question to chew on as you evaluate your own architecture. Are we engineering AI as a heavily sandboxed, untrusted component with strict runtime boundaries, or are we blindly trusting it as an enterprise silver bullet? How you answer that question today is going to determine the resilience of your infrastructure tomorrow. Now, for more deep dives into cloud, security, and AI insights exactly like this, you should definitely subscribe to the YouTube channel at AL Estrin. Keep learning, keep questioning, and we'll catch you in the next explainer.